Hello, this is Teacher Peter, and in this video I will look at part 2 of this topic. This is indices and surds. Remember, part 1 we tackled surds. Now in this topic, part 2, we will look at indices. Now, without wasting much time, let us look at the rows of indices. We have several rows of indices. The first row of indices is the product row, whereby we have a product of let's say two numbers having the same base but different powers. So for such kind of a case, we normally add the indices. We normally add the powers. So we normally add the powers. The second row is on division. This whereby we have same base but different index or different powers. Then we have division. So what we normally do, we minus the power. So we minus the power to get the solution. Now the third row is whereby we have power of a power. So power of a power, this means we have, let's say, a power n, then raised to power n. So this is just equal to a, then you multiply m and n. You multiply n and m as the power. So you can see it very well there. The other part, the other row of indices is the power of a product. So we can have a multiplied by b raised to just one power. So this just means a power n, then multiplied by b power the same n. So as given there. The other row of indices is whereby we have power of a quotient. This one is power, but we have two numbers dividing but sharing the same power. So this means it will be for this case here, a divided by b power m, it will be a power m, then divided by b power the same m. Finally, we have two rows of index that are specific. So whenever you have power over 0, that is any number power 0, then we will get so whenever we have power of 0 or any number raised to power 0 is just equal to 1. Power of 1, so any number raised to power 1 is just equal to itself. So if you have 5 power 1, then that's just 5. So these are the rows of indices that we will use in the exercise that follows. Now we have question number 1 here, states that simplify using index row. So whenever we have any multiplication, any kind of multiplication, we are multiplying numbers, so that means we add the index, we add the powers. So therefore you multiply, in this case here we have to multiply by d power 3, then e, this is just e power 1, then multiply by 5, multiply by d power 4, and multiply by e power 2. Now here you first of all multiply the coefficients. 2 by 5, that is 10. Then we will have D and E. Now consider the let me first of all remove that. Okay, consider this one here, the powers of D. In the first term we have 3, so it will be 3 plus what? Plus 4, that is power. Then we have E we have 1 plus what? Plus 2, and the final answer will be 10 D power 7, then E power 3. That becomes the answer. Now when it comes to part B, whereby we are dividing, when it comes to division, then we use power we use number 2 here, whereby we minus the powers, we minus the powers. So therefore what we get here will be so we are having 6s power 3 t power 1 over, this is 3 power 3, then s power 2 t power 1. Now as we know, we first of all deal with the coefficient. You can divide by 3 1, by 3 2, so we are getting 2. Then when it comes to dealing with now the powers, we have s that is 3 minus 2, that is the power. Then we have t 1 minus 1, and the final answer becomes 2. 3 minus 1 is just s power 1, then t 1 minus 1 is just 0. So we saw that a power of 0, anything raised to power 0 is just equal to 1, anything raised to power 1 is just equal to that number. So therefore this one here will be, we will be getting 2, this is s, then t power 0 is just 1, and therefore the answer becomes 2s. 2s is the answer. Now let's proceed and see another question. Question number 2. Use the appropriate index row to simplify the following. Now we need to simplify this. Use the appropriate index row to simplify. Here we have 4 d power 4 e power 1 then squared. What does that mean? So everything inside we have to square. Remember 4 is power what? Power 1. So therefore we means that we multiply all the powers by 2 here. So therefore we will be having, this is 4, 1 multiplied by 2 is 2, so 4 squared, then d 4 by 2, and e 1 by 2, and finally we have, this is 16 d power, that is 8, and e power 2. That becomes the answer. We multiply. So we are using which law? The row that we are using here is law number 3. This row here, number 3, whereby we multiply the powers. We multiply the powers. Now the next question, part B, we're supposed to use the appropriate row to simplify. Now the first row that we have to use here is just the row that we have used here. We need to multiply the powers, so this is just equal to 5 power 1, then g power 3, and s power 2, and t power 0. then we all raise them to power 0. So we multiply everything by that power, so it will be 5 power, that is 1 multiplied by 0. Then G, we have 3 multiplied by 0. Then we have S, 2 multiplied by 0. And finally we have T, 1 multiplied by 0. So what do you get? We get 5 power 0, G power 0, S power 0, and T power 0. And we say that using now the 6th row of indices, that is this row here, anything raised to power 0 is just equal to 1. So therefore all this will give us 1, and 1 is the answer. 1 is the answer to that. We proceed to the next question. Find the value of A in the following questions. Find the value of A in the following questions. Now here, this is a set of questions that require us to find that A. So in the first question we have 2 raised to power A minus 1 then is equal to 32. Now, so this means that we need first of all to write 32 as a base and index, whereby the base must be equal to 2. So this means have 32, you divide this 32 by 2, you get 16. Then 16 you divide by 2, you get what are you getting? You get 8. Then dividing 8 by 2, you get 4. 4 by 2 you get 2, and 2 by 2 you get 1. So how many 2's do we have? We have 1, 2, 3, 4, 5. So therefore this can be written as 2 power 5. And finally now we can say that 2 power A minus 1 is equal to 2 power 5. Now since the bases are the same, then even the powers are the same, so we can cancel the bases and now work with the powers. So this means that A minus 1 is equal to 5. So what is the value of A? Take this one on the other side. Since it is minus, then when it crosses the equal sign, it will change the sign to be plus, and therefore A becomes 6. So 6 is the value of A in the first question, part A. Now when we talk about part B also require us to do some mathematics. So here we have this being equal to 4 power A is equal to 1 over 64. Now the same way we need to express 64 as a base and index, and the base must be 4. So therefore let's have 64. So 64 divided by 4, we are getting, this is 1, and then 24 divided by 4, that is 6. Then divide by 4, we are getting 4, and then finally divide by 4, we are getting 1, and therefore 64 can be written as 4 power 3. Now so we are having 4 power A is equal to 1 over 4 power 3. Now all that we are having here, we can now reciprocate this part here, finding the reciprocal of it. Then we will get 4 power a is equal to 4 then raised to minus 3, and therefore since the base are the same, the index must be the same, and therefore a becomes negative 3. So whenever an index is negative, if you find the reciprocal of it, then it becomes positive, as you have seen. So that is part the question number 3. We still have more questions. Let's see. Question number 4. Find the possible pairs of positive integers for x and y in the following questions. So we have these questions here. The first question is x power y is equal to 64. So I need to divide 64. Dividing 64 by 2, we get 32. Dividing by 2, 16. By 2, we get 8. By 2, we get 4. By 2, 2. And finally by 2, 1. So therefore, how many 2's do we have? 1, 2, 3, 4, 5, 6. 6. But okay, we are seeing 6 2's. There is also something I want us to see. There is also something that I want us to see here. That thing is, if you join these two, you get 4. Multiply by 4. Multiply by 4. There is also something I want you to see, that we can also use 3 2's from here going up to there. That is 8, and then from here going up to there is 8. So we are having 3 categories. We can write 64 can be written as 2 power 6, can also be written as 4 power 3, can also be written as 8 power 2. So therefore, all these are the categories or the possible integers of x and y. So x is the base and y is the power. So the first category of x and y is 2 power 6. So meaning that x there, that is x, y. X there is just 2 and y is 6. The second category of x and y is 4 power 3, meaning that 4 will be x and y becomes 3. And the final category is 8 power 2, whereby 8 is x and y becomes 2. Hope you have understood what we have done very well. Once after we have multiplied, after we have splitted this 64 into the simplest or into the prime number, then after that we have seen how we can also find get the 4 and also get the 8. To the next question, we are having x power y being equal to 1. Now in each category here, we can now go back to the rows of indices. To the rows of indices, if you look at row of indices number 6, power of 0 So anything raised to power 0 is just equal to 1. And the other thing is the number 7, power of 1, that anything raised to power 1 is just equal to 1. Now, performing this question here, using those row of indices, I can say that 1 power 1 is equal to 1. So therefore, the first set of x and y becomes 1 and 1. So this is the first set of x and y, because it's giving us 1. Anything raised to power 1 is just itself. So 1 raised to 1 is just 1. The next category is whereby we have any number x raised to 0, then this one will be equal to 1. And therefore, here we have a lot of set of numbers. Because any number raised to 0 is just equal to 1. So raise any number to 0, then you get 1. And therefore, here y will be equal to 0, but x will be numbers from, let's say, 1 up to infinity. We can also have negative 1 up to negative infinity, all those numbers being equal to what? Equal to 1. So therefore x will be changing while y here remain 0. But the first category, or the first pairs of positive integers, positive integer means that we will do away with the negative here, but we will just look at the positive integer. Positive integer is from 1 to infinity. So x will be from 1 to infinity, but y becomes 0. Now, the next concept is about negative indices. So if any number is raised to a negative indices, that means that any number raised to a negative indices, and so negative n, this becomes 1 over n, then that becomes a positive. So you find the reciprocal of that number for you now to make the index positive. Now, for example, we have a question here. Express the following in simplest form of positive indices. So if you have a negative index, then make sure that for you to express it as a positive index, then you have to find the reciprocal of it. Okay, now with what we have here, we can use row number 2, and the row number 2 here is about the division law. We minus, whereby we are doing what? We minus if it's for division. There we are. So therefore this will be, we can first of all divide the coefficient by 3, 1 by 3, 2. So we are having 1 over 2. This is x power minus 2, then w power 3, then we have x power negative 3, and w power negative 2. Now this we are supposed to express everything by what? As a positive index. So doing the reciprocal, then this means that it will be x, remember 1 over 2 will remain, then it will be x power 3, then W is also negative power, so W power 2, and then the other one at the top will go down. That is now the reciprocal. We are doing the reciprocal. That is 2, and then W will be, no, W will remain there because W is positive, so W power 3 will remain at the top because it's positive. So therefore the final answer will be, if you take this negative 2 here, will division law means you minus at x there, and therefore we will be getting x power 1, W power, you add, this is 5 over 2. The answer becomes x W power 5 over 2. That's the answer. To the next, that's the simplest answer. To the next one, we are multiplying, but still you can see there is a minus and whatever. So first of all we can combine them all. So you can multiply the coefficient here, multiplying the coefficient 6 multiplied by 3, 6 multiplied by 3, we are getting 18. Then we have a power 4. This is 4 minus, we are supposed to add, so it will be minus 6. Then b power 3, then plus 1. So therefore the first one will be 18, a power minus 2, then b power 4. So we need a positive index, so therefore this will be 18 sorry, will be equal to 18 b power 4 over a power 2. So that is, we have found the reciprocal of a power negative 2 to get a positive power positive 2, and that is the answer to that point. The other part, which is the final part here, is question number 7. So for x in each of the following, so here also we just do the same idea. We have 27 here, so this 27 have to be written as a base and index, and the base should be 3. So therefore this will be 27. You divide by 3, dividing by 3 you get, that is 9, divide by 3 you get 3, dividing by 3 you get 1. So this is just can be written as 1 over 3 power 3. 1, 2, 3, 3 power 3. So therefore we have 3 power x is equal to 1 over 3 power 3, and you have said this one can be written as 3 power reciprocal of it negative 3, and because 3 and 3 are the same, we can cancel the base and deal with the index. So index are also the same, and x now becomes negative 3. So x is equal to negative 3 to the first question. Second question now, okay, dictate us that also we should write 216 as base and index, but to the base must be 6. Therefore we are dividing everything by 6. If you can divide this to 16 by 6, what are you supposed to get? What are you supposed to get? Divide by 6. You will get this is 3 because of 18, then 36 is 6, then divide by 6, you get 6, divide by 6, you get 1. So 216 can be written as 6 power 3, and therefore we can say 6 power x is equal to 6 power 3. And since the bases are the same, so cancel the bases, and then x becomes 3. So x is equal to 3. That's all about using index rows. Thank you very much for being with me. See you in the next video. Thank you.